So you may have noticed whenever we calculated the energy transfer of this system, we never actually found out what the mass of our aluminum was. And so I wanted to make a video just kind of explaining how we can calculate the mass of aluminum using a concept that I really want to go over in this video, and that is that our energy transfer from our aluminum into the water is equal to the energy transfer into the water from the aluminum. And if you think about it, that makes way too much sense, that our Q would equal our Q. That our energy transfer from our aluminum into our water is equal to the energy transfer into our water from our aluminum. And so what we can actually say is our energy transfer into, and let me pick the right color here, into our aluminum is equal to, well, what we found out earlier for the energy into the water, which was 20,920. And let me add my units here. But the reason why this is remarkable is before we use the mass of our water, our specific heat capacity of our water, and our change in temperature of our water to solve for energy. Now we're going to use that energy, so we're going to use the Q of aluminum, let's say, our energy transfer from, and let me actually pick the right color again, the energy transfer from our aluminum to solve for our mass, assuming we know everything else. So we don't know our mass of aluminum, but we do know our specific heat capacity of aluminum using our chart, and we can figure out the change in temperature of our aluminum. And actually, let me go ahead and separate this so we can see the difference between our new work and our old work. Let me actually go ahead and separate this as well. And let's go ahead and figure out the rest of what we know and what we don't know. So we already wrote down what our Q of A is. We're looking for our mass of aluminum. We know our specific heat capacity of aluminum. We just look here at our chart, our specific heat capacity of aluminum. So our C of A is 897, and our unit is joules divided by kilograms times degrees Celsius. So joules divided by kilograms times degrees Celsius. And so we know that. And do we know our change in temperature of aluminum? Well, the change in temperature of aluminum, let's go ahead and write this out. The change in temperature of aluminum would be the original temperature, or the difference between the original temperature and the final temperature. So we could say, and let me pick my right colors here, we could say our final, or our original temperature of aluminum, I'm sorry, minus the final temperature of the aluminum, which is of course just the final temperature of the entire system. Everything in the system is the final temperature. Well, that's pretty simple. We can plug these numbers in pretty quickly. We could say our original temperature of our aluminum block was 80 degrees Celsius, and we're subtracting our final temperature, which is 30 degrees Celsius. And so what do we get for our change in temperature of our aluminum? We get, well, 80 minus 30 is a change in temperature of 50 degrees Celsius. And if you're wondering why our change in temperature of water was only 5, why it was so much smaller than our change in temperature of aluminum, the reason is if you look at the temperature of aluminum, it goes from 80 degrees to a final temperature of 30 degrees, whereas the water only went from 25 to 30 degrees. And so there was a much more drastic change in temperature in aluminum, so that's why that number is higher. That just makes way too much sense. And so with that, we have everything we need to solve for our mass of aluminum. Let me go ahead and extend this. And then let's just plug in our numbers and see what we get. So we know our Q of A is 20,920. And since we're running out of room, let's just go ahead and scrap our units. We know our final mass is going to be in kilograms. If you don't believe me, you can go ahead and see how your units cancel out. Let's set that equal to our mass of aluminum multiplied by our specific heat capacity of aluminum, which is 897, multiplied by our change in temperature of aluminum, which we just said was 50 degrees Celsius. And so to solve for this, all I'm going to do is just get mass of aluminum by itself. So on both sides, I'm going to divide by 897 and 50. So I'll put 897 on bottom, and then I will put, let me get the right color here, 50 on bottom, and I'll do the same thing over here. We'll divide by 50, and we'll divide by 897. And so on the right, that cancels out, and on the left, we'll figure this out. We'll just plug it into our handy-dandy calculator. We'll take 20,920, and we'll divide that first by 897. And then we'll take that number and divide it by 50 degrees Celsius. And what do we get? We get 0.466, and let's round it off there. So we get our mass of aluminum is equal to 0.466, and our unit is kilograms. And of course, we can then convert it if we want to. We can say our mass of aluminum is also the same thing as saying 466 grams.